Hello. In this video, I will do a practice mode regarding algebra and functions for the IBEW aptitude test or the NJATC aptitude test. So yeah, this is for all IBEW, IBEW exams or NJATC. So this is algebra and functions, and this is not timed. This is a practice mode. So when I do these problems, I'm going to take my time and I'm going to explain it very carefully. But when you do the real exams, you will have a time limit, and I believe it's like I believe it's just double check. You have like for the math, so there's a math and a reading part. So for the math, I believe you have like about 33 questions and you have to do it in 46 minutes. So you only have like a minute to do each problem. So that's why you got to practice. So let's start with question one. So like I said before, I'm going to take my time and I'm going to explain it very carefully. So question one says simplify the following expression. We have 2 parentheses 3x squared, 2x cubed minus 9 minus 4x squared minus 5x plus 1 minus 3x cubed plus x squared. So I know what you're thinking. Why can't I just FOIL out this 2, collect like terms, simplify? You could do that, but let's make our life easier. So what I would do is simplify the inner parentheses. So what I would do is go with the highest power and go down. So what is our highest power? It looks like we have an x cubed. Yeah, my highest power is x cubed. So what you want to do is circle or box or underline anything that has an x cubed. So I have a 2x cubed here and negative 3x cubed. And let's just clean that up. So that's going to be, so I'm going to bring out that 2. I'm going to follow out that 2 later. So what is 2x cubed minus 3x cubed? It is negative 1x cubed. Now, what about the x squares? You can box or circle. So, you have a 3x squared here, a negative 4x squared there, and a positive x squared there. So what is 3 minus 4 plus 1? 3 minus 4 is negative 1, plus 1, that cancels, right? There's no more x squares. So all the x squares cancels. Okay, now let's do our x's. So x's, we have a negative 5x. That's it. So just bring that down. And then my constants are negative 9 and positive 1, so that's negative 8. Okay, so that makes it a lot easier. Then you can FOIL out the negative 2. So this is going to be negative 2x cubed. This is going to be negative 10x. And then this is going to be negative 16. Okay, so that is this answer. Negative 2x cubed minus 10x minus 16. Oh yeah, I forgot to tell you, I'm using the program IPrep. Um, I don't know if that is interest, but yeah. Okay, I can check with this one. So it tells you the answer, if it's correct or not. So it is correct. Okay, let's move on to question two. So yeah, if you're actually using iPrep, you can just log into your account and then, uh, yeah. So question two says, consider the following. We have this polynomial y equals 2 times 2x plus 1 times x minus 1. So what I would do first is, so they want you to FOIL out and collect like terms. What I would do first is FOIL out the this, the 2x plus 1 and 2x minus 1, right? Okay, FOIL that out. So that's 2x times x is 2x squared. 2x times negative 1 is negative 2x. 1 times x is x. And then 1 times negative 1 is negative 1. Okay, clean that up. So that's going to be 2x squared. Negative 2x plus 1x is negative x minus 1. And then I may FOIL out everything by 2. Okay, so when I FOIL that 2, that's going to give me 4x squared minus 2x minus 2. Okay, so is that going to be the second one? Okay, not too bad. If you need to pause the video, go ahead. But pretty straightforward, right? Okay, so the green means correct. Okay, question 3. Clear real quick. So question 3 says factor out the polynomial. So be careful. If you can't see this, it's x raised to the negative 2 plus y cubed plus x cubed. How do I factor this? So it's kind of like going backwards. They want it factored. Um, so we have x. Hold on. This is question 3. So we have x to the negative 2. That's not a positive 2. It's a negative 2 plus y cubed times x cubed. So we got to factor out GCF, greatest common factor. Now, if you look at this carefully, we have two terms. This is one term. This whole thing is one term, right? This whole thing, y cubed, x cubed. Now, what do you think we can take out? What do they all have in common? I believe we can take out x's. How much? That's the difficult part. Yeah, so we got to be careful. This is a negative 2. Um, we can take out x's. We can't take any y's because this first term does not have any y's. So what is this largest amount of x's we can take out evenly? Yes, we can take out x to the negative 2, and I'll show you why. So we can factor out x to the negative 2, but we still can't change this problem. So I'm going to put a little bracket or a little parentheses if you want. So we can't change our problem. So what do you have to multiply x to the negative 2 to get the first term, x to the negative 2? 1. Now, this part is a little bit tricky. What do you have to multiply x to the negative 2 to get the second term? Y cubed, x cubed. Now, I'm going to tell you there you got to use this exponent rule. So we're technically foiling, so we're technically multiplying. So when you're multiplying, for example, x5 times x3, you add the power. So this would be x to the what's 5 plus 3? 8. And then and if you have like x5 times x to the negative 2, you're adding. So what's 5 minus 2? 3. And then another exponent rule we need to know is dividing. So let's say you had x5 divided by x3. When you're dividing with the same base, you subtract. So that's going to be x to the 5 minus 3, which is 5 minus 3, which is 2. Okay, so what do we have to get? What do we have to multiply x to the negative to get this entire second term, y cubed, x cubed? You're going to need a plus, and you're going to need a y cubed. And what else? What else do we need? So this one's tricky. So what do you have to multiply x to the negative 2 to get x3? So you're going to need an x, and you're definitely going to need a positive power, and it's not going to be 3. It's actually going to be 5. So why is it 5? Because remember when you're multiplying, you're adding. So what is x5 times x to the negative 2? That is x to the 3. Okay, we want x3. So that's why I use x5. And we can't factor this anymore. So what's our answer? It is this one, right? This is x to the negative 2 times 1 plus y cubed x5. So it is this one. Okay, so you just have to know your exponent rules, and you can just figure out what is your GCF. Factor the polynomial. So this one, I'll show you, you kind of need to know your factoring rules. This one, we got to factor x squared plus 6x minus 27. So we're going to use simple factoring, but first you always got to check if you can factor out a GCF, greatest common factor. So we have three terms, we have x squared, 6x, minus 27, right? Those three terms. There's nothing we can take out evenly. We can't take out an x because this negative 27 does not have an x, right? We can't factor a constant because there's no number besides one that'll divide evenly. So then you got to figure out what factoring method. So I noticed there's no number in front of the x squared, so there's like an invisible one. So when the a value is one, you're going to do what's called simple factoring. Your teacher might call it X method. It's the same idea. So what you got to do is write out two parentheses. I'm going to put an X here and an X there. And then I'm going to put a blank space here. This is always the tricky part. Um, so you have to come up in your head, come up with two numbers that multiply negative 27, and then when added gives you positive 6. So that's right. What two numbers multiply negative 27 and added gives you positive 6? So you might have to do some more trial and error. So on top of my head, I know that 9 times negative 3 is definitely negative 27, right? Then you add those two numbers. What's 9 plus negative 3? That is positive 6. So yes, they both work. So it's going to be plus 9 minus 3. Okay, so it's this one. Correct. Okay. So yeah, that was factoring. Okay, now we're dealing with sequences. So number 5 says, what is the next number in the following series of numbers? So in sequences, you're probably using arithmetic. So in arithmetic sequence, you might have what's called a common difference, right? So you either add or subtract a number. Yeah, so you have a common difference in an arithmetic sequence. And then you might also have a geometric. In a geometric, you have a common ratio. So that means you multiply by a number, common ratio. So 2, 6, 8, 2 is like the first, I'll call it A1. A1, 6 is the second number, so I'll call it A2. 18 is the third number, I call it A3. 54 is the fourth number, A4, right? So, um, I know I don't think it's going to be an arithmetic or geometric. Sometimes you're going to have a neither, and you just have to figure out a pattern. Why do I think it's not a geomet arithmetic? Because 2 to 6, what did you have to add or subtract? 4, right? To get to the first term to the second, you had to add 4. And then to 6 to 18, uh, what did you have to add or subtract? Uh, yeah, what did you, it's not consistent. So yeah, you would have to add 12. As you can see, this is no longer this is no longer arithmetic sequence, because you went from 6 to 12, that it has to be the same number constantly. So that's why it's not an arithmetic. Let's try, does it have a common ratio? So you can find the ratio is what you could do is do the second term divided by the first term, and then that should give you the third term divided by the second term. So what is the second term divided by the first term? So 6 divided by 2 is 3. So let's see if this works. So from 2 to 6, you definitely had to multiply it by 3. So from 6 to 18, you definitely had to multiply it by 3. And 18 to 54, you definitely have to multiply it by 3, right? 18 times 3 is 54. So this proves that we have a geometric sequence, and we have a common ratio of 3. So all you got to do is to get the next number, you just multiply by 3. So what's 54 times 3? 162. So that is why it's this one. So sometimes you might have an arithmetic sequence, sometimes you might have a geometric, sometimes you'll have neither, and you just got to look at the pattern and figure out what would be the formula. Okay, so here's another sequence problem. Question 6. We have 15, 10, 12, 8, 10, 7, 9. We got to figure out the next number. So let's test if it is an arithmetic sequence. So this is like your first term, second, third, fourth, fifth, sixth, and seventh. So from 15 to 10, you probably have to subtract 5, right? And then 10 to 12, you had to add 2. This automatically proves that this is no longer not arithmetic. But let's keep on going. From 12 to 8, what do you have to do? I believe you have to subtract 4, right? 12 minus 4 is 8. And then 8 to 10, you had to add a 2. And then from 10 to 7, I believe you had to subtract 3, right? 10 minus 3 is 7. And then 7 to 9, I believe you had to add 2. Okay, so this is definitely not arithmetic. And I also don't think we have a common ratio. I don't think we have a, I don't think we have a geometric because is there a number that you multiply constant to get a constant term, right? No. 10, what do you have to multiply 15 to get 10? Like 0.6. It's not consistent. So we know it's not arithmetic and not geometric. Okay. So we just have to look at the patterns and go from there. So from -5 to, let's look here. So we subtracted 5, we added 2, we subtracted 4, we added 2, we subtracted 3, and we added 2. So what do you see that they all have in common? You had to add 2 on the second choice, right? Um, yeah, you had to add 2. There's a pattern for the 2s. So -5 plus 2, -4 plus 2. Oh, these differences is I'm adding 1. So -5 plus 2, and then -4 because you added 1 from -5, and then added 2, and then -3 because you added 1 from -4, right? Plus 2, and then it looks like we have to add another 1 on the minus. So what's -3 plus 1? -2. So the next number is this number, -2, which is 7. So yeah, that can be tricky, especially when you're doing time tests. Uh, yeah, that can be tricky. But yeah, that's how I would do it. Look at the pattern and go from there. 7 says, what is the next number in the following sequence? So we're dealing with sequences. So is this a geometric or arithmetic? So let's see here. So from 2 to 5, what did you have to add? 3. From 5 to 11, what did you have to add or subtract? You had to add 6, right? 6 plus 5 is 11. So I I don't think it's neither an arithmetic or geometric. And because it's why do I believe that? Because the number for arithmetic has to be constant. You have to add 2 constantly, or if you have to subtract 1 constantly. And I know it's not a geometric because it's a number that you multiply constantly. So from 2 to 5, what did you have to multiply 2 to get 5? You could just do 5 divided by 2, which is not that nice. It is 2.5, and 5 times 2.5 is not 11. See, that's why it's not geometric. So you're just gonna have to continue with the pattern. So from 11 to 23, what did you have to add? I think you had to add 12, right? From 11 to 12, 11 to 23, you had to add 12. And then from 23 to 47, I think you had to add 24. So what do you see? Is there a pattern? You added plus, this is a plus 3, by the way. Plus 3, plus 6, plus 12, plus 24. It looks like you're doubling each time, right? 3, and then from 6, you had to double that amount. From 6 to 12, you had to add double that amount, and then 12 to 24, you had to add double amount. So the next one is you have to double that from 24. So what's 24 times 2? 48. So you're gonna have to add 48 from the last term. So 47 plus 48 is 95. So yeah, that's how I got 95. So yeah, you just have to look at a pattern. Number 7 was the next number in the following numbers. We have 2, we have 5, 11, 23, and 47. So yeah, I don't think it's a geometric or arithmetic. Let's see. From 2 to 5. Oh, sorry, this is the same problem. I didn't say next. That's why. But that's correct. Okay, this is the next problem, now question 8. So question 8 says, what is the next number in the following series of numbers? We have a 50, we have a 34, 26, 22. So let's see here. So from 50 to 34, what did you have to add or subtract? I think you had to subtract 16. From 34 to 26, you had to subtract -8. And then from 26 to 22, you had to subtract 4. So I know it's not an arithmetic or geometric because arithmetic, the constant has to be the same. And then geometric, there's no number that multiplies constantly, right? But we got to look at the pattern. So we went from 16 to -8 and then -4. So they're all negatives. The only thing is you're taking it at half each time, right? -16 divided by 2 is -8. -8 divided by 2 is -4. So the next one has to be -4 divided by 2, which is -2. So I think you have to do the last term, 22, and then you have to subtract 2, which is 20. Yeah, I think the next term is 20. Okay, let's do question 8. What is the next number of the following series of numbers? We have 50, 34, 26, 22. So let's see, what did you have to add or subtract from 50 to 34? Oh, same problem. I need to go to the next. Okay, here's the next one, and it's a sequence problem. So in this one, question 9 says, we have 5, 6, 11, and 17. What would be the next number? So from 5 to 6, you had to add 1. From 6 to 11, you had to add 5. From 11, 17, you had to add 6. So I know it's not arithmetic or geometric, but look at the pattern. You went from 1 to 5 and then 6. So I think from 5 to 6, you had to add 1. So I think, yeah, I think you just have to add 1. So I think the next one you have to add 1. So it would be 7. So what's 7? So the next term would be 17 plus 7, which is 24. I don't see a number. No, 5 plus 6 is. Oh, hold on. I see it. Never mind. This one's a tricky one. So I don't think you add 7. That's wrong. But what do they see carefully? Oh, I see. Do you see the pattern? So from here, this plus 5 is the same thing as this number here. And then this plus 6 is the same number here, right? So the next number will have to be the same number as this, right? So you have to add plus 11. So what's 17 plus 11? It'd be 28. So yeah, I think it's the last one. Yep, correct. Number question 10 is also a sequence number. So we have 2, 6, 3, 9, 6, right? Let's see. From 2 to 6, what do you have to add? Plus 4. From 6 to 3, I think you have to subtract 3. And then from 3 to 9, you had to add 6. And then from 9 to 6, you had to subtract 3. So, do you see a pattern? I don't really see one. It goes from 4 to -3 plus 6, -3. Mm, not really. The only thing I see is like there's a -3 here and here. So maybe if addition doesn't work, is there a number that we multiply instead of it adding or subtracting? So let's do this again, but let's use a multiplication factor. What do you have to multiply 2 to get 6? I would say plus times 3, right? And then what did you have to multiply 6 times 3? 6. What did you have to multiply 6 to get? 3. Oh no, I think you have to subtract 3. Maybe we'll have to do a multiplication and a subtraction. So from 6 to 3, you have to subtract 3. From 3 to 9, you'd have to multiply by 3. And then from 9 to 6, you had to subtract 3. So now I see the pattern. It's a multiplication of 3, and then subtraction of 3, and then a multiplication of 3, and then a subtraction of 3. So the next number should be a multiplication of 3. So what you're going to do is multiply 6 by 3, and I see the 18. So this sequence is an alternating between arithmetic and geometric. Okay, so that would be 18. Okay, question 11. So now we have this formula, parentheses 3a times parentheses 2b, so plus c parentheses parentheses minus 2 equals bc over bc plus a. And they tell us a few things. They say that b is 5 and c is 6. What is the value of a? So what can I do here? They want you to solve for a. They give you some values. Should I plug in my values first and then simplify, or should I just kind of clean it up, then plug in my values? So this is what yeah, I would definitely just clean it up. So the only thing I could clean up right now is this parentheses, right? 2b plus c minus 2a. So you have this minus here, so it's going to be 3a, and then distribute this minus, so it's going to be negative 2b minus c, and then this minus 2 is outside the parentheses, so you have to bring it down, equals to bc plus a, right? So, can I simplify the inner parentheses? No, because they're different letters. So now what I would do is just plug in my values. So it's going to be 3a, I don't know what a is, minus 2 times b, b is 5, minus c, which is positive 6. So there's a minus in the positive 6. And then minus 2 equals to b times c. So b is 5, c is 6, and I don't know what a is. So clean this up a bit. 3a, negative 2 times 5 is negative 10, minus 6, minus 2, 5 times 6 is 30, plus a. So this is all without a calculator because you can't use a calculator on the exam. Clean it up. So 3a, and then I'm going to clean up this. So what's negative 10 and a negative 6 and a negative 2? So negative 10 minus 6 is negative 16, minus 2, so that's negative 18, right? And then you have 30 plus a. So our goal is to solve for a. So what I would do is maybe get all the a's on one side. So you have an a here and a 3a there. So maybe I should move this a to the left by subtracting a. Okay, so 3a minus a is 2a minus 18 equals to 30, right? Solve for a by adding 18 to both sides. So you get 2a equals to 30 plus 18 is 48. Divide this by 2, and I get 48 over 2 is 24. Okay, so my a value is 24. Yep, so that's how I would do this problem. I would not plug in my values yet. I would simplify and then plug in my values. Okay, well, let's do question 12. Same thing like 11. They give you this equation. They give you some values. A values 2, C values 10. What is B? So before I plug in my values, maybe I should clean it up a bit, FOIL it out, and then move things around. So on the left side, the only thing I can really do on the left side is FOIL out this B. So this is going to be, um, hold on, maybe B is, yeah, maybe I should, on the left side, actually, maybe I should clean this up first. I think that's much easier. So on the right side, we have 50, and then it's a minus parentheses B, and then I would FOIL out this. No, you know what? Maybe I should just plug in my values. I think that would be easier. So my C is 10 and my A is 2. So let's do that. On the left side, my C is 10, so let's do 10 times B. We don't know what B is. Minus 3 equals 50 minus parentheses. My B, I don't know what B is, plus A. My A is 2 times B plus 1. So B, not sure, plus 1, and then parentheses followed by another parentheses. So what I would do first is you have two parentheses. So I would do this inner parentheses, but B plus 1, there's nothing you can simplify, but I could file out this 2, so that's what I should do. So it's going to be 2B plus 2, and then you have this B right here, right? And then inside this parentheses, before I distribute this minus, I can combine the B's, right? You have 1B and a 2B. That's 3B plus 2. And then I think I should, on the left side, maybe I could FOIL out that 10. So that's 10B minus 30. Then I may FOIL out this minus, so this is going to be negative 3B minus 2. And then what's 50 minus 2? 48. And then we have 10B minus 30. Okay, go ahead and solve for B. So maybe I could add 30 to both sides. So this cancel. Let me put it up here. So you have 10B equals to 40 plus 30 is 78 minus 3B. And then get all the B's to one side. So add 3B, add 3B. So 10B plus 3B is 13B equals to 78. Divide this by 13. So B is 78 over 13 is 6. Yep. Okay, so yeah, we're gonna stop to 33. So let's continue. So let's move on to 13. Simplify the following expression in the simplest form. We have a cubed plus a over a plus c plus b times b minus c minus a squared. Consider b equals 5 and c equals negative 8. Maybe I should just plug it in, or yes or no. What I would do is, like, I know this is really annoying. The slanted, I'm going to rewrite that as I'm going to rewrite that as AQ plus A all over A, because that slanted can always make you confused, right? There's a slanted and then there's another. It's just confusing. And then here is plus C plus B times B minus C minus A squared. Before I plug in my values, I could simplify this side, right? A cubed plus A divided by all A. So you're dividing each term by A. So really it's like A cubed over A or A1 because it's invisible 1 plus A over A, right? So what's A cubed divided by A1? You're dividing with the same base, so that is subtraction. So that's A squared. What's A over A? 1 plus, then maybe I should plug in my values. So my C is -1. My B is 5. B minus C, so my B is 5. Minus C is -1, so -1 minus A squared. Wait, what are we trying to find? We are trying to find, they don't give us an A. Oh, I see. So we're supposed to simplify. So let's simplify this parentheses. So what's -1 plus 5? 4. What's 5 minus a minus 1? Two negatives becomes a positive, so that's 6. And then you have a minus A squared. You have this plus 1 here, and then you have this A squared. So then what I would do is I can see that A squared and negative A squared cancels. And then you have a 1. And then what's 4 times 6? 24. So what is 24 plus 1? 25. So that is how I got 25. So yeah, I just cleaned it up, then plug in my values. Okay, let's move on. Question 14. We have A equals 7 minus B. So A equals 7 minus B. We got to figure out which of this statement is true. So yeah, which of this statement are true? If A if A is less than -7, then B is positive. If A is greater than 7, B is positive. If B is greater than -7, A is positive. If B is less than -7, A is negative. What would I do? Maybe I would isolate the variables. So we have one variable isolated, right? It's A equals 7 minus B. What about if we isolate B? What would that be? So I would have to subtract 7, get rid of this minus by dividing everything by -1. So I get B equals to negative A plus 7. I'm going to box it, and then I'm probably going to have to fill in, I'm going to box this as well. So this is going to make our life easier. Let's just plug in values. If A is less than -7, so what's a number less than -7? You could do -8. Does that mean B is going to be positive? Let's see. If A is -8, so if A is less than negative, so maybe I'll put it back here. So if A is -8, so it's going to be B equals minus, and then A is -8 plus 7, and then a negative and a negative is a positive. A plus 7 is definitely positive. But yeah, I think that comes out true. Um, You could test each one, and then I already did this. This is false, this is false, this is false. So in this problem, it's okay to plug in values. Later on in these kind of problems, plugging values isn't always going to be helpful. You might have to graph it because this is a linear line. You could have graphed this using in the Cartesian plane and do the linear line thing. But this one you could just get away with plugging the values because you would just test each value and then figure out when it's true. But there will be times where it could be tricky to test values, so it's best to use a graph. So yeah, A. Let's move on to 15. Consider the following formula: x equals 0.5y plus 6. So this one, I think it's best to graph it. So this is definitely a linear line. Um, if you need, okay, so how do you graph a linear line? You could get y by itself. So this is a linear line. And what you want to do is put it in the form of y equals mx plus b, right? And what you need to do when you graph a linear line, you need to find the slope, which is basically the number in front of m, and then find your b. That's one way of graphing a linear line. So that's what I'm going to do. I'm going to solve for y, but the only problem is 0 0.5. I have this decimal. I don't like it. I can rewrite 0 0.5 as 1/2, right? 1/2 is the same thing as 0 0.5. And what I would do is get rid of the fraction. That would make our life so much easier. So to do so, I'm going to multiply everything by 2 because that our common denominator is 2, right? So I'm going to multiply everything by 2. So 2 times x is 2x. What's 2 times 1/2 y? Well, the 2's are the same, so your 2's cancel, you're left with y. And then what's 2 times 6? 12. So I did that to get rid of the fraction. Now I'm going to solve for y, so I'm going to subtract 12. Subtract 12. So I get y equals 2x minus 12. So I'm going to put the 2x first, and then the constant negative 12. So I got to figure out my m and my b. So my m is 2, and my b is negative 12, right? So how would I graph this? So this is my graph. You can do the rise over run method, plot the b, and then do the slope, rise 2 over 1. Um, or you could just find the x-intercept and the y-intercept, right? I think I should do that. I'm not going to graph this using the rise over run method. Um, just going to graph this by finding the y-intercept and the x-intercept. So we already have the y-intercept. Our b is the y-intercept. So my y-intercept is negative 12. Or you could write it as a coordinate as 0, comma negative 12, right? And then let's find the x-intercept. How do you find the x-intercept for this graph or any graph in general? You simply set y to 0 and solve for x. So it's going to be 0 equals 2x minus 12. And then you solve for x, so you're going to add 12. Add 12. You get 12 equals to 2x. Divide this by 2. You get x equals 6. So my x-intercept is 6 comma 0. Okay, so I'm going to plot those 2 points and you'll get your graph. So I'll show you why this graph is important because just plugging in values won't work this time. So let's see, my y-intercept is 0, comma negative 12. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then my x-intercept was 6, positive 6. Here's the x, here's the y-axis. So 1, 2, 3, 4, 5, 6. Okay, dot it. Connect those 2 points, and you got your graph. So if you forgot how to graph a linear function, um, if you forgot how to graph a linear function, you can go over one of my videos, in the linear function section, and it shows you how to graph a linear function by scratch. So that's only if you don't know how to graph a linear function or if you completely forgot, right? So that's one way of graphing a linear function though. So this graph I'm going to label as y equals 2x minus 12, which is the same thing as this. Okay, so this is a linear function. The only thing is it's in standard form. So we're going to use this graph to answer this. So let's see if part A is true. When the value of y is greater than -6, x is positive. So is this true? When the value of y is greater than -6, x is positive. So when the value of y, so the y is on the y, this line, this vertical axis, right? When the value y, when the when the value of y is greater than -6, so on the y-axis, locate -6. Here, let me put more marks here. Oh, great. -6, -1, -2, -3, -4, -5, -6, right here. So when the value of y is greater than -6, so anything larger than -6, so that includes -5, -4, -3, -2, -1, and 0, the x is positive. I think that might be true because at -5, what is the y value? I mean, what is the x value? It's somewhere right here, which is positive. -4, it's still positive, right? Positive, 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 and even 0. When the y value is 0, the x value is +6. And then if you go even beyond, like 1, yeah, yeah, definitely true. This is definitely true. What about, I just want to show you, why doesn't the rest work? So what about B? When the value of y is lower than -6, x is negative. So anything below -6, so that includes -7. So at -7, right, when the y value -7, what is the x value? It's positive. But if you keep on going, so like below, because they want to lower than -6, so that includes -12 and beyond. So if you continue this graph, right, and if you do -13 and beyond below, so -13, the x value now becomes -1, somewhere in the negative value, and then -14, it also becomes negative. So that's why it can't be this one. What about C? When the value of y is greater than -12, x is negative. So here's -12. When the value of y is greater than -12, the x is negative. No. So anything above -12, so -11, the x value is positive. -10, it's positive. That's false. What about D? When the value of y is lower than -12, x is positive. When the value of y is lower than -12, x is no. Anything below -12, like -13, the x value is negative. So the only one that is true is A. So in this one, we had to draw the graph, and then we gotta evaluate the graph. Because if you plug in values, there are some that might be partially true, so that's why we can't just like plug in values like in the other ones. So this one here, consider the graph y equals 2p plus 2, 16. Y equals 2p plus 2, and we gotta figure out which one is true. So in this one, yes, I think we have to draw a graph. Um, or do we? So W is 2p plus 2 minus p. Actually, I don't think we don't have to draw the graph. So what we could do is W equals 2p. Just substitute. So on the, yeah, we'll just test each one. So part A says the difference between the values of W and P changes. So what did that mean by the difference between W and P? So it's really W minus P. And then what we'll do is substitute W with 2P plus 2. So 2P plus 2 minus P. And then what's 2P minus 1? 2P minus 1 is P. So you get 1P plus 2, right? So this is 1P plus 2. Well, yeah, the difference between the values of WP changes. Yes, that's true. Um, yeah, that's definitely true. You could graph this on a linear, this is technically a linear line, but thing is, this is it's like we're doing different letters, so we're dealing with W's and P's. So this is a form in the form of y equals mx plus b. And the only difference is our y is W and my x is P. That's the only difference, right? So if you want to draw this, it's fine. We can draw this by doing the rise over run method. So it looks like my M is 2 or 2 over 1 because it's the number in front of X or P, and my B is 2. If you kind of draw it on a Cartesian plane, um, keep in mind our X is what P, so this is like P, and then my Y is W. Okay, so my B is 2, and then my slope is 2 over 1, so go up 2, 1, 2, right 1. So this is W equals 2P plus 2. The difference between the value of W and P changes. Yeah. Um, yes. As you can see, as bit P changes, the Y value changes, right? If P was 1, it would be somewhere here, and then if the P is 2, the W is this value. If the P is 3, the W is a different value, right? So they changes. So that's why it's true. The difference between the values of W and P are constant? No, right? Over here, your P value is 1. Your W value is, I don't, it looks like it's somewhere between 3. They're different values, so they're not constant. Um, for the positive W values, the P value is greater than 0. No, because if you look at 0, what is the P value? 2. So uh, it has to include 0, so that's why that's false. For negative p-values, W is negative. So negative p-values, no. If you have a -1, the p-value is positive here. I mean, if you continue going negative, it could be definitely negative, but not always negative. So this is not always true. So the correct answer is A. Okay, 17. Consider the following linear graph: 2.5x equals 7.5y plus 50. I know that's a linear because it's just in standard form, right? In a linear line, it could be in the form of y equals mx plus b. It can also be in standard form ax plus by equals c, right? So this isn't standard. What I would do on this is 17, I would probably graph this, right? I would graph this. Yeah, I would graph this. What I would do is, how would I graph this? Maybe I hate decimals, so what I could do is to get rid of this decimal is multiply everything by 10. Because if you multiply everything by 10, all you got to do is move the decimal one place to the right. So what's 10 times 2.5x? Just move that decimal one place to the right and you get uh 25x. Over here, what's 10 times 7.5? You move that decimal one place to the right, so that is 75y. And then what's 10 times 15? 150. So what I would do is I'm not going to solve for y and do the rise over run method like the other problems. What I would do is to graph this, I would find the y-intercept and the x-intercept. That's how you can graph a linear line. So let's find the y-intercept. Okay, to find the y-intercept, all you got to do is set x to 0 and solve for x. I mean, solve for y. So it's going to be 25 times 0 equals to uh, 75y plus 150. And this cancels, so you're just left with 0 equals to 75y plus 150. Solve for y, so I'm going to subtract 150, subtract 150, get negative 150 equals to 75y. Solve for y, so you divide this by 75, 75, and you get y equals to 75, negative 150 divided by 75. Without a calculator, that's doable. That is negative 2. So you have a y-intercept at 0, comma negative 2. Now let's find the x-intercept. So how do you find the x-intercept for any graph? You simply set y to 0 and solve for x. So it's going to be 25x equals to 75 times y plus 150. So I know this cancels, so you're left with 25x equals to 150. Solve for x, so I'm going to divide this by 25. And you get 150 divided by 25 is doable without a calculator. I think that is going to be 6, right? 6 times 25 is 150. Okay, so our x-intercept is at 6, comma 0. So all you need is 2 points to graph a line. We have an x-intercept of 6, comma 0, and a y-intercept of 0, comma negative 2. Okay, so go ahead and graph. Okay, so our x-intercept is at 6, comma 0. So here's the x, here's the y. So 1, 2, 3, 4, 5, 6, dot it. And then my y-intercept was 0, comma negative 2. Okay, so here's negative 2, dot it. So dot those 2 points, connect the dots, and you got your line. So this line is the same thing as this line, right? Now let's, based on that line, let's figure out what is true and what is not. So when the value of y, so here actually let's move more tick marks. So when the value of y is less than negative 2, x is negative. Is that true? When the y when the value of y, so look at the vertical line, this y-axis. Anything when the value of the y is less than -2. So here's -2. Anything smaller than -2. So that includes -3, -4. So when the value of y is less than -2, the x is negative. So here at -3, when the y value is -3, the x value looks like it's negative. When the y value is -4, it's also negative. Even at -2.5, the x value is negative. So that's definitely true. I think that's always going to be true. What about B? When the value of x is less than 15, y is negative. So when the value of x is less than 15, positive 15, right? When the value of x is less than 15, so that includes 14, 13, 12. So if you continue, this is 15, so 14, y value is negative. Not true, not always true. So right here, if you do 1, positive 1, that has a positive x value, right? If you continue this graph, the y value, yeah, the x value is positive. Um, Even if you have 14, the x value is positive. So, oh, sorry, I got that mixed. It was when the value of x is less than 15. So we're doing this line, horizontal. So here's 15, continue the line. No, not true, because if you do 14, the y value is positive, right? 14's here, the y value is positive. 13, the y value is still positive. Anything, I think if you go below 6, it's negative. So it is partially true. Anything below 6, the y value is negative, but anything above 6, like, but less than 15, so 14, the y value is positive. So that's not always true. What about C? When the value of x is less than 6, so here's 6, the y value is positive. Nope. Here's 6, anything less than. So if you did 5, the y value is definitely a negative. Uh, 4, the y value becomes negative, right? So that's not always true. D, when the value of y is greater than -5, x is positive. When the value of y is greater than -5, when the value of y, so look at the y-axis, anything, locate where -5 is. Uh, when the value of y is greater than -5, so that includes -4, the x is positive. Nope. At -4, because this line extends, at -4, the x value is negative, right? So that's not true. So that's why H, letter A. Okay, let's move on. 18 says we have 1/2 x equals 2 minus 1/4 y. Which of the following statements is true for this? 18. Yeah, this is a linear line problem, and I think we've got to graph this. So the good news is it's in terms of x and y. The bad news is it's like a fraction. So what should I do? I could graph this just finding the x and y intercept. I don't have to get y by itself. I think we can just get away with the fraction. So let's find the x-intercept. So to find the x-intercept for any graph, you simply set y to 0 and solve for x. So you have 1/2 x equals 2 minus 1/4 and replace y with 0. Okay, so this is going to be 1/2 x equals to 2. And then when you cross multiply or multiply it by 2 to get rid of this 1/2, you get x equals 4. So my x-intercept is at 4 comma 0. Okay, now let's find the y-intercept. So to find the y-intercept, you simply set x to 0 and solve for y. So it's going to be 1/2 times 0 equals to 2 minus 1/4 y. So this is going to be 0 equals to 2 minus 1/4 y. And then solve for y, so you're going to subtract 2. You get -2 equals to -1/4 y. And then get rid of this -1/4 by multiplying everything by -4. Okay, so -4 times -2 is +8, and then this is just y. So you have a y-intercept at 0, 8. Okay, plot those 2 points and you've got your graph. Okay, so my x-intercept is 4, 0. My y-intercept is 0, 8. Okay, connect it. You got your graph. So now we're going to see which one is true and which is false. So is A true when the value of x is less than 4? So the x value, look at the horizontal axis, less than 4. So that means that includes 3, 2, 1, etc., right? You gotta also use -1, -2. So when the x value is less than 4, so let's try 3, the y value is negative. Nope. Here's 3. What is the y value? It's a positive value, so that can't be true. What about B? When the value of x is greater than 4, so that includes 5, 6, and beyond, right? When the value of x is greater than 4, the y is positive. That's false. At 5, the y value slowly becomes negative. Like this could be like -1. And then at 6, it gets more negative. So that's false. What about C? When the value of y is less than -6, x is positive. So look at the y-axis. If you need to extend this line, that's fine. So here's -6. When the value of y is less than -6, x is positive. Yes, I think so. Because here's negative. If you go negative, like even -1, wait, and the value of y is less than -6. Yeah, this could be -6. The x is positive. Yes. At -6, this x coordinate is positive, right? At -5, this x value is positive. -4, this x value is positive. So that's true. What about the third one? Last one? When the value of y is greater than -6, so greater than -6, so that could be -5, right? The x is positive. No, because greater, okay, so they're saying when the value of y is greater than -6, that includes 0, 1, 2. So at 1, the x value is positive. But if you go higher, maybe like 8 or even 9, the x value now becomes a negative. So this isn't always true. So C is the only one that's always true. When the value of y is less than -6, so -6, -7, -8, the x value is just more positive. It's just positive no matter what. So C. 19. Which of the following statements is true for this formula? This one, 19. I don't think you have to graph this as a linear line. You could graph it, but yeah, you could graph it, or you can actually substitute values. So what I mean is, here, I'll show you. By the way, if you do graph it, uh, the slope is 1 and the b is 1, right? And then the t is like your y and your g is like your x. So that's the only difference. You kind of have to change your boundaries. So it would look something like this. Whoops, x is g. So this is the g axis, and then y is t. And I said, let's see, plot some points. Okay, so if you graph this, the slope is, the b is 1, so your y-intercept is, I'm going to graph this using the rise over run method. And then my slope is 1. I mean, my y-intercept is 1, and my slope is also 1. So what you do is from the b, you go rise 1, run 1, rise 1, run 1, right? And it looks something like this. Now, um, the, you kind of have to figure out the domain and range. So the domain is all the x values, and because this is a linear line, the domain is all real numbers, so you can use negative infinity to positive infinity. And then the range is also real numbers, right? Negative infinity. So range is the y values, or the, in our case, the t values. You can use positive and negative y values because this extend. Okay, what is g plus t? So what I would do is, I know this, like, you can't really plug in values, like, so what I would do is substitute my value. So t says it's g plus 1. So if you look at the first choice, it's g plus t. So what I'm going to do is replace my t with g plus 1, right? Because that's what they said t was. So it's going to be g plus 1 is greater than 0. So that means, if you simplify this, what's g plus g? 2g plus 1 is greater than 0. And then if I, oops, this is 0. And then if I subtract 1, you get 2g is greater than negative 1. Okay, so this is why I kind of drew the graph. So for the domain for g, you can use all real numbers. You can use a positive one, you could do 0, you could do 0, 1, 2, 3, 4, you could do negative 1, negative 2, negative 3, because the domain is all real numbers. So this is why it's not always true, because let's say you use a g value negative 10. That's part of our domain. You can use negative 10. So 2 times negative 10 is greater than negative 1. Is this a true statement? No, right? 2 times negative 10 is negative 20. Negative 20 is definitely not greater than negative 1, so that's false. So that's why it can't be that one. What about B? So let's do B. So what I'll do is replace this t with g plus 1. Here, let me erase. I need more space. I know it's hard to like do all this in less than a minute, right? Or a minute. But if you practice enough, it shouldn't be too hard. Yeah. So let's look at B. So it's t plus g is greater than 2g. So what I'm going to do is replace t with g plus 1. plus g is greater than 2t. So let's see here. What's g plus g? 2g plus 1 is greater than 2t. Wait, whoops. What I would do is replace this t with g plus 1. So it should be 2 times and replace t with g plus 1. So that's 2g plus 2. Now, what I notice is they both have a 2g, so you could just ignore that, and you're just left with the statement 1 is greater than 2. Is this true or false? False, right? 1 is definitely not greater than 2. What about C? What's g minus t is greater than 0? So, let's see. Is this true? So what I'll do is g minus t is greater than 0, so that would be, so I'm doing C. So it's G. So I'm going to do C. And I'm going to replace G with, I mean T with G plus 1. So it's G minus parentheses, and then replace T with G plus 1. Is that greater than 0? Let's see. So if I fill out this minus, this is going to be negative G minus 1, and then you have a G here. Is that greater than 0? So this cancels. And then you're left with negative 1 is greater than 0. Is this true? No, that's false. Negative 1 is definitely not greater than 0. So you can forget about C. Now let's do D. So yeah, what I'll do is substitute my T with G plus 1 and then simplify from there. So it's going to be T minus G. So replace this T with G plus 1. So it's G plus 1 minus G is greater than G minus T. So it's G minus, and then we're going to replace T with G plus 1. Okay, let's clean this up. So on the left, the G and then negative G cancels. You're left with 1. And then over here, you have G. And then FOIL out this negative. So this is going to be negative G and then negative 1. Okay, so the G's cancel. So you're left with 1 is greater than negative 1. Is this true? Yes. You put it on the number line. 1 is, put the larger number on the right and then the smaller one on the left. 1 is definitely greater than negative 1. So this is the only one that's true. That's why it's D. Okay. This one, consider the graph y equals negative x plus 1. By the way, that's a linear line. Which of the following choices represents the same relationship with the given function? So they want to know which one is true. So looking at the choices, there's one that I can forget about immediately or cancel. B. Why can I get rid of B? Because that's not a linear line. That is an absolute value that has a reflection rate, so it can't be B. Let's see if A works. So they give us a table. Let's see if this really is a true table. So our function is y equals negative x plus 1, right? And then I'm going to replace my x. Let's try when I plug in negative 2, does it really spit out 1? So if I plug in negative 2, oh, okay. If I plug in negative 2, this is going to be minus and then replace x with negative 2 plus 1. So what's that going to be? That is going to be positive 2 plus 1, which is not 3. It's supposed to spit out, which is 3. It's supposed to spit out 1, so that's false, right? So we said B is not true because it's a absolute value. Let's try C. So if I plug in 1, I get uh, negative 1 plus 1 equals to 0. Yes, that's true. Let's try a few more. If I plug in 10, we can do this in our head. What's negative 10 plus 1? Negative 9. Yes, that's true. If I plug in 100, what's negative 100 plus 1 is negative 99. Yes, so that's the only one that's true. So I'm going to say C. Okay. Yeah, let's stop here at 21 because, yeah, let's stop here at 21. Let me put a question. No, my notes. Yeah, this is too long. Let's make it into two parts. So let's stop at 21. Okay, I will see you for the next part of this video.